Now, let's move on to Kepler's law. John Kepler proposed three elegant laws known as Kepler's laws. These laws helped Newton to give the universal law of gravitation. First law of orbits. All planets move in elliptical orbit with the Sun situated at one of the foci of the ellipse. On the ellipse, the closest point from the Sun is P and the farthest point is A. P is called perihelion and A is called aphelion. S and S dash are the foci of the ellipse. AP is called the major axis. The perpendicular on AP that passes through the midpoint is the minor axis, that is BC. The length of major axis is 2A and length of minor axis is 2B. Second, law of areas. The line that joins any planet to the Sun sweeps over equal area in equal interval of time. Suppose the 2 days planet moves from P to P dash. The planet takes the same time to travel from Q to Q dash. Then, according to law of area, triangle PSP dash equals to triangle QSQ dash. This law comes from observation that planet appears to move slower when they are farther from Sun than when they are nearer. No more. The law of areas can be understood. No more. The law of areas can be understood as a consequence of angular momentum, which is valid for a central force. A central force is such that force on the planet is along the direction joining the Sun and the planet. Let the Sun be at origin and let the position and momentum of the planet be denoted as R and P respectively. Then the area swept out by planet of mass m in time interval delta t is given as delta A, where delta A equals to half of R cross V dt. Hence, dA by dt equals to half R cross P by m, since V equals to P by m. Thus, dA by dt equals to L by 2m, where V equals to the velocity, L is the angular momentum equals to R cross P. For a central force which is directed along R, L is constant as the planet moves around. Third, law of periods. The square of time period of a planet is proportional to cube of semi-major axis of the ellipse traced by the planet. Suppose the time interval, that is, time required by planet to complete one revolution is t and semi-major axis is OA. The length of OA is r. Then according to Kepler's law, t square is proportional to OA cube, that is, t square proportional to r cube. Note that the table gives the approximate time period of revolution of 9 planets around the Sun along the values of their semi-major axis. Data from measurement of planetary motions given below confirms Kepler law of period, as t square divided by a cube is proportional to same for all the planets. Hence, Kepler law's period is verified.